Hello, this is LA Rathbone. Welcome to the next episode of the GTK4/GObject tutorial. This episode is about list views, column views, and GTKExpression. Now, on the last occasion, I indicated that I was going to stop numbering the videos. That is still true, but I do recommend that you watch the last video before watching this video. So the last video was about interfaces in GObject and list models. And this video does take some of those concepts and uses them, builds upon them to talk about what we're going to talk about here. So I do recommend watching that video first. Now, the two types of main widgets that we're going to look at in this video is a list view and a column view. And if we take a look at two arbitrary demos, there's a bunch of demos that we're going to look at in this tutorial, but let's just take a look at two here. This is a very, very simple demo that shows a list view. So what it is it's a one-dimensional list of items, row by row. You see the first one says foo, second one says bar. Nothing happens when you click on them, but you can click on them, select them, and so on and so forth. Easy, or simple to look at anyway. Not so easy to write code, but we'll go through that soon. And then a column view has multiple columns. You'll see here first column and second column, and then each row has a item per column. But what's interesting is in both of those last cases, each type of widget, so the list view, that's one-dimensional, or the column view, which is multi-dimensional. Either way, you still have a one-dimensional list model behind the scenes that is feeding the objects on a row-by-row basis to the widgets. So you sort of have to think, when you're dealing with a list view, it's easier because it's one-dimensional anyway, so each sequential item in the list model, you can conceptualize how that would just plug into a one-dimensional list in a list view. But for a column view, you kind of have to start thinking about how you're going to represent more than one thing per row, but where it's still one GObject per row. And so that's something that we're going to tackle and show you how to deal with in this episode. So let's jump right in. Let's take the first code sample, which is lv1.c, which is the first example of a list view. So we're going to skip some of the boilerplate stuff with the main and the activate. But when we grab our list view, and by the way, like I've said before, this is all on the GitLab repo, so you don't have to worry about looking at all this code line by line right now. You can always take a look at it on the GitLab repo. The link is going to be in the show notes. So to create a list view, we've created a little helper function called createListView. Simple enough. So let's jump over to that function. So like I said before, all list views and all column views are, at the end of the day, backed by a list model. So we need to create a list model of some kind. Now, in the last occasion, we created a customized list model, and we could still do that. But GIO, which is part of glib2, actually comes with one out of the box. And so it's called a glistStore. So we're going to actually utilize that instead of our customized widget that we created last time, because quite frankly, their version is probably better than ours and has more functionality. And it comes with glib2 anyway, so we might as well use it now that we've gone through the exercise of creating our own, right? So we create a list store by calling glistStore new, and then we give it the G type of what we want to be, what the object type is that we want to have contained within the list store. And in this case, we're going to use the GTK string object type, which is what we did last time. And then we actually have to create something called a selection model, because the list view doesn't want a raw list model. It wants a special type of list model called a selection model. And so there's many to choose from. I can't go through all of them right now. We're going to use the single selection model because it's the simplest one. And when you create a single selection model, what you do is you call GTK single selection new, and then you pass to it a list model that it will utilize. And so what we're going to do is call store to it, but we have to cast it as a glist model. Fine, done. That's how we create the selection. And as you note here in the list view new method, it needs a selection model, and it also wants what's called a factory, a GTK list item factory. And so we have another helper function to go ahead and create that factory. So let's take a look at that. So what we do is we create the factory. We create a helper function that returns a GTK list item factory star, and it creates it using GTK signal list item factory new, because there's more than one type of GTK list item factory. One of them is a signal list item factory that you plug into signals, and you tell the factory how to create items through those callbacks. Another way to do it is through a builder list item factory, which uses XML files, which we'll show off a little bit later on. So there are multiple types of callbacks you can connect to. And let me take a look. If I take a look at the GTK signal list item factory documentation, right? If we look at the signals, there is bind, setup, teardown, and unbind. For the purpose of a simple example, we only need the bind and the setup callbacks to be implemented. So that's why we only have those two here. So what the setup does is, because list items and list views and column views reuse widgets, it breaks things down and says, okay, tell me what kind of widget you want to utilize for the row in question, and tell me how to instantiate it, and just create a raw basic widget, and we'll figure out what's going to go into that widget later. So that's what the setup callback does. So all we really do here in the setup callback is we create a label, because it's just, we don't want to, you can put any widget into a list item that you like. We just want a label just to keep it just text-based. And so we create a GTK a label, and then we call GTK list item set child. Now the child that you're setting of the list item has to be a GTK widget. And so that's why we picked a very simple one that can hold text, being a label, and we go ahead and do that. Now, if you take a look at the documentation, the bind and all the other callbacks for that matter actually have a prototype that looks the same as ours to begin with, but then instead of having GTK list item star, they've got a GObject star in there. But you can expect it to be a GTK list item star of some kind, or it could be a derivative thereof. And so we haven't bothered putting it as GObject as it is in the documentation, and then creating a whole nother guy here, casting it, and everything like that. We've just jumped a step ahead and just assumed it's a list item and put it here in the callback. And again, that's how you set the child to be the label, just the plain label, the vanilla label that we've gone ahead and created. And then the other callback is the bind callback, which actually, here's where we'll focus a little more on what's happening. So what happens here, when you've gotten this far as the bind callback, what's happening is the list item factory is going ahead and saying, okay, we are somewhere in the sequence of the list model, and I'm giving you a list item. Here it is. It's the second parameter. And you can expect that list item to be a GObject that corresponds with where we're at position-wise in the list model. And so if you go ahead and say get item on that list item, you land up getting the object that's associated with the position that the list item is in the list model sequence. And since we already told the list model that it was going to be holding GTK string objects, we can expect GTK list item get item to give us the string object that pertains to where we're at in the sequence. And so we do that, and then when we call get child, that's just pulling the child widget from when we set it in the setup callback that pertains to, again, the widget in line with where we're at in the rows. So we grab the child, and then because we're binding the because we're binding the text that is, in this case, in the sequence of where we're at in the list model to the widget, we just call the standardized GTK label set text function, and then we grab the string from the string object and we plug it into the label, and then everything is going to work just great. And so that's how those callbacks work. And so that's what we did in the create factory function. And then we've got enough information to build the list view. Okay, so GTK is happy. But at this point in the sequence, we haven't actually added anything to the store. So we're going to then rectify that by now this helper function adds stuff to store, which is going to go ahead and add, it's going to create two string objects called stirObject1 and stirObject2 containing the strings foo and bar. And then we're going to append to the list store those string objects. And now because GListStoreAppend is what's called transfer none on the receiving end, that's just a fancy way of saying that when the ListStoreAppend method is called, the ListStore takes a ref on the object that's passed in. And for some reason that kind of confuses me sometimes, because transfer full when you're the guy receiving the object means that you're getting a ref, whereas transfer none on the receiving end means that you're getting a ref. So it's like almost like the opposite of what you might think, but it kind of makes sense because transfer none means they're not taking ownership, meaning that you can go ahead and free the guy that you have passed to it. And so you know, you have to sometimes just look it up as to what it means. But transfer none means that it takes a ref. So that's why we're using the auto pointer here, because it's going to go ahead and free these string objects when they get out of scope, because the ListStoreAppend has already taken a ref on them. That's what transfer none means on the receiving end. Kind of confusing, but that's the way that it works. If you didn't use auto pointer, then you'd have a memory leak here if you didn't manually free the string objects at the end of the function right here. But no need to bother with that because we have auto pointer. And just a little word of note here as we finish analyzing this function. Now I can kind of talk about what this comment means here. Although we have some objects that are transfer full on the creation end, they should not be freed at the end of the scope because they're ultimately consumed by GtkListView new on the receiving end. So we talked about in this case up here, transfer none was what's happening on the receiving end. But if we look here, GTK, in this case, for example, single selection new. Let's check the documentation. Like I said, it takes a list model, but the parameter is transfer full, you see, which is different than up here, where in this case it was transfer none. So because it's transfer full in this case, they are taking ownership, which means they're not taking a ref of these objects, and so you don't want to free them at the end of the function. And so we'll see in the next example what would happen if you did use auto pointer, but as you'll see when we do look at that example, there's a good reason why we don't want to use auto pointer in this case. Anyhow, so that's what we do. We go ahead and get the list view, and then everything should come together at that point. So let's take a look at LV1 one more time. There you have it. Foo and bar are the string objects that are bound to those labels in those spots. Great. So let's take a look at LV2. So this is exactly the same as the last example, except with some of this transfer none and transfer full stuff, I've tried to use auto pointers in all cases to show you how you would deal with that if you did want to be, I guess you could say, consistent and use auto pointer in all instances. But you'll see here, like I just said, why it's not always the best idea. And so we already talked about how this works. So this is not changed because we already used auto pointer before. But what happens if we go ahead and use auto pointer in the create list view function? Now, since, as I indicated before, these guys here, GTK single selection new and GtkListView new, are transfer full on the receiving end. If you do use auto pointer, you have to be very careful. So we've instantiated, we have declared and initiated to null, initialize rather to null, all of these objects that we are using now as auto pointers. And so we're going to create them all in the same way, except that now with the selection guy, for example, instead of just calling glistModel on store, we're going to call GStillPointer on the address of store, so that then it passes the address of what's baked into the store pointer to the single selection new function, but then it nullifies this guy up here. And so what that means is when we get to the end of the function and it goes out of scope, it will not try to free it, because if it did, that wouldn't be good, because the selection guy took ownership of it, meaning it did not take a ref on it, meaning the only ref that we had is now destroyed at the end of the function, and you're going to run into trouble. So if you're going to do it this way, you've got to use GStillPointer in this instance. And then here, we've now got to use it twice, because GtkListView new is transfer full on the receiving end, and so it does not take a ref of the selection or the factory. And so if we left it alone and did not use GStillPointer but did use the auto pointer here, they'd be destroyed at the end of the function, and then things would start to mess up or crash, right? And then even in the return value of the statement, of the function, we have to use GStillPointer, because the list view, the whole point of this function is we're creating a list view and returning it to the activate function. And so if we didn't use GStillPointer here, the list view that we've tried to return would be destroyed at the end of the function because of auto pointer. And then by the time we get here, it would be no good because it'd be destroyed. And so the take-home message here is that you can use auto, like, it's tempting to just want to use auto pointer all the time, but if you do, you have to be very careful, because you have to be aware of whether or not items on the receiving end or the giving end are taking refs or not taking refs, because it's going to make a difference if you pass an object to another function, but then you destroy it at the end of the scope. That's no good. So you need to be aware of it. I personally think that this is a good example of why you shouldn't always use auto pointer, and you might want to just do it the way that we did it before. And so, but if you do take a look at what we've gone ahead and done with the LV2 example, you'll see that it does work fine, and everything is exactly the same as it was before. So now let's take a look at LV3. Whoops, there is no LV3. I lied. Let's take a look at CV1, which is the first example of a column view now. And this example is going to be somewhat contrived because, like I said, I'm trying to break everything down nicely. And so we're going to pick things up where we left off before. Instead of a create list view function, we're going to have a create column view function. And we're only going to create one column in the column view called my first column right here. And you'll see here that as opposed to the list view, which itself has a factory associated with it, in a column view, each column has a factory associated with it. So if you've got one column, it doesn't make much of a difference. You're pretty much doing things the same way as you did before, except now you have a column header. And so I won't walk you through all these things one by one. The concept is almost exactly the same as it was before, except that we've gotten rid of some of our auto pointer madness from the last example. Otherwise, everything is pretty much the same, except things have been slightly modified to accommodate for the fact that we're using a single column view now. And if you take a look at this example, it's pretty much the same as it was before in terms of you have the foo and the bar, except that now you have technically a column, one column in the column view, and it has a label, a header at the beginning there. But otherwise, not too interesting. So let's take a look at how we would add multiple columns. So we'll take a look at the CB2 example. And again, it still is somewhat of a contrived example because we're not, well, you'll see what it looks like in a minute, but we're not going to have proper columns that have separate entries on a per row basis. So we'll create the column view in the same way with helper function. Now if you look at the helper function, we're creating two columns called my first column and my second column. But we're going to see what happens if we use the same factory, right, on both columns. And so we add stuff to store in the same way. We add two columns instead of one, but we still have a one-dimensional list of string objects in the list model that's backing everything. And so what we'd expect to see here, and you'll see the rest of the code is all the same, what you'd expect to see here, if things work out properly, is two columns, but they should have the same content in each one. Let's see if that's what happens. Yes, it is. So we've got my first column and my second column, but they both got the same data in each one on a row by row and column by column basis. So that's not really too useful, but it does at least show that this is how you instantiate different columns and to have data that pertains to each column. But remember, each column has to have a separate factory, and yet you've still only got a one-dimensional object that's backing the whole column view. So now, like I said before, you've got to start thinking about how do you keep things one-dimensional and yet also be multi-dimensional. Well, the way to do that is to conceptualize things and to say that, well, okay, so you can only have a one-dimensional list of objects in the list model, but that object doesn't have to just have one piece of data in it. It can have multiple pieces of data in it. So what we're going to do now is we're going to create a customized object that we're going to put in the list model that's going to have the ability to have a different string on a per column basis. Okay, so how do we do it? Well, let's take a look at cb3.c. So everything's the same here, but let's take a look at our helper function. When we go ahead and create our helper function, we're now going to create two factories and two columns like we did before, my first column, my second column. And we're going to add stuff to store, except that now the store is not going to have GTK string objects in it. It's going to have a customized object called a demo string tuple. Okay, so what is that? Well, it probably makes sense to look at that before continuing. So we create a customized object called a demo string tuple. You know, not going to walk you through the boilerplate code because we've done it many times before, but there's two properties in the demo string tuple. We're going to be super de-duper creative, and call it string 1 and string 2. So as you may be able to imagine, string 1 is going to be the string that is connected to the first column, and string 2 is going to be the string that's connected to the second column. And all the object contains is, well, we got our GObject parent instance here, but it's a stir1 and a stir2. And then we go ahead and create the type right here. The set property function simply duplicates the string that's sent to us by way of the setter by gvalue. And then the get property function simply, again, just passes what the contents of the string to the gvalue in question. Nothing very interesting about that. You'll note, though, that we haven't used helper functions here, and that, jumping ahead a bit, as you'll see in a second, can kind of send a little bit of a hint to you because you're not seeing a GObject notify by pspec function here that we're not using explicit notify because it's just it's a simple object and it doesn't do very much, and so we might as well just use automatic notification, which does help things a little bit. So the finalize function simply frees the strings. Nothing too interesting about that. The init function does absolutely nothing because there's nothing to do. But the class init function sets up the properties and makes sure that the stir1 and stir2 properties are construct properties, that when you create an instantiation of the object with GObject new, you can tell it right off the bat what stir1 and stir2 are going to be and what their contents will be. No need to mess around here. Just do it quick and dirty and get it over with. So we've been extra verbose here, and we've got the setup one, the bind one, the setup two, and the bind two. We've just really been super explicit and copied and pasted some things to have everything set up one by one for the first factory for the first column and the second factory for the second column. So the setup functions are not too interesting, same as before. All we do is we set up a vanilla label, plug it into the list item, and you basically get a different list item on a per column basis with a column view. So be aware of that. Now bind one simply grabs where we're at in the list model, and then if we're at position, the first position or the second position or what have you, it doesn't really make a difference what column we're in. All that matters is you got one object that pertains to that position in the row. And so therefore, if it's bind one and we're dealing with the first column, we're going to take the stir1 property, and we're going to plug that into a string, and then we're going to set text on the GTK label that pertains to where we're at in the column and in that position, and set the text thusly. And then the setup 2 callback is the same, and the bind 2 callback is exactly the same as the bind 1 callback, except that we're using stir 2 rather than stir 1. And so when we add stuff to the store, it's a bit different than it was before because we are creating a demo string tuple rather than a GTK string object, and we are going to add 2 to the list store, and for the first one, stir1 is going to be foo, stir2 is going to be bar. For the second one, stir1 is going to be baz, stir2 is going to be boo. And then we append them to the list store, and again, because glist append takes a ref, we need to free these guys that we've created at the end of the function. So we use auto pointer, and by the way, gdeclare final type automatically adds auto pointer functionality to our customized objects. So that's pretty nice. And creating factory 1 and 2 is not too surprising what happens. We're being very, very verbose, but we're just trying to keep it simple so you can really see very clearly what's going on. And so if you take a look at now what we've created with CB3, we go ahead and run that program. You got the first column, second column. The first one's got foo and bar, stir1 and stir2 for the first tuple in the list model. And then the second one's got baz and boo, again, stir1 and stir2, the strings that are the stir1 and the stir2 from the second tuple in the list model. Okay, hopefully you're starting to see how this is all coming together. So let's take a look at CV4, and this is where we clean things up, buddy. All right, so believe all the stuff pertaining to the demo string tuple is the same as before, so we'll bypass all that, and we'll just show an example of how we can clean things up a little bit and get rid of some of the duplicative code. And so if we jump to the create column view function, you'll see here, and I won't really go over this in too much detail, you can look at it on your own time, but instead of having a create factory 1, create factory 2, and bind 1 and bind 2, and all that stuff, we just created some more genericized functions that actually take, so we can create a factory, right? But it takes a car star of the property that we want to create a factory and have it bound to. And so if you see here, we pass str1 to it, and we pass str2 to it, but we're just reusing code. The little comment here is just me being very pedantic. Why do we have to cast this prop here to a G pointer with our callback function? Well, it's because we've told it up here that createFactor takes a const char star, but the gsignalConnect macro expects a non-const generic pointer, and so if we don't cast it to a G pointer here, the compiler is going to complain and say, well, you might modify it, and even though you said it was const up here, and so we put that cast in there to basically shut up the compiler. Even though I'm not a fan of casts in general unless they're necessary, in this case it kind of is necessary. So that's what we do there. And then we add stuff to store. It's the same as before, except that now we've been a little less lazy asses and we've created a constructor function that is a little more user-friendly than it was to use GObject new manually before, but the rest is the same, I believe. Everything up here is the same. And so let's make sure that everything looks the same as before. Yes, it does. So no surprises there. So we got one more example here for column view to look at, and then we're going to go ahead and look at how to do more of the heavy lifting using UI XML files. So what have we done here? Let's see. We create a column view, same as we did before. Nothing is too different here. The only difference really in this code example is that we've now rewritten the bind callback to use a new concept that we're going to start to talk about in this episode, but we will talk about it in a later episode too, because it's a very complex area and it's really not enough time in a single episode to get into the details of it. But we're going to rewrite the bind callback using something called GTKExpression. Now, what we basically do in pseudocode is instead of manually grabbing the objects before and plugging things in them, we're saying now let's bind one property to another property. And the property that we're going to bind is we're going to go ahead and grab whatever property it is that we're going to have in question from the string tuple. So you can either in this case, you can basically either pass str1 or str2 to this function, and then it's going to plug it in here. And in pseudocode, it's going to look up the list item, which we know is a tuple. So we're going to basically, in pseudocode, we're basically casting it to a tuple. And then we're grabbing the str1 or the str2 property, depending on what's been passed to the function. And then we're going to bind that property to the label, which is the child of the list item. And so in order to do that, we use two expressions and we stack them together. So the first one is we go GTK property expression new, and then we pass the G type of what we want to look up, and then it's going to look up the property of the item. Okay, so we know that what we're going to get from that is a glist item, which we know is a tuple. And then we're going to create another expression called expression2. And in that case, it's going to expect to get the tuple, which we now pulled using the first expression. And it's going to take a property from that. And that property is the one that we passed to the function. So it's going to be str1 or str2. And then it's going to use this GTKExpression bind function to take the second expression, which is stacking of xpr1 and expr2, and it's going to then bind what we extracted from these properties to the label. So it's going to take the list item, it's going to grab the str1 or str2 property, depending on what we pass to the function, then it's going to bind that property to the label property of the label. So in other words, it's basically going to take the str1 and plug it into the label, or the str2 and going to plug it into the label. But it's going to do it in a more generic fashion than explicitly telling it, okay, GTK label, set text, and all that stuff. And there may not seem to be much point to that when you're looking at it in code. But when you do things in XML, it's basically doing this kind of thing behind the scenes, and it can be nice to know what's happening behind the scenes. And that's why we've shown off how to do it in this manner. So let's just take a look at the CV5 demo, and things are working exactly the same as they were before. But it's just that we've no longer used manual GTK methods. We've used GtkExpression now to bind the tuple str1 and str2 properties to the label that's pertaining to the list items. So pretty advanced stuff. So that takes us through the examples that are done in pure code. So what if we wanted to get rid of some of the C code, pare things down a bit, and do things in XML? Well, okay, let's take a look at the cv-ui.c file and the corresponding cv.ui file. So this is the second last example here. So boilerplate, fine. And then instead of creating a column view in code, we're going to get the object from the UI file. And the only thing that we're going to do manually here is we're going to, well, first of all, I mean, we're creating a window manually rather than doing it in XML, but we'll do that differently in the final example. I'm just trying to show things one by one here. The only thing that's going to be built in the XML file here is the column view itself, to make it easy to see what's happening. And so we grab the object, and then we still codify this by setting up the column view, by creating our list store with the tuples the same way as we did before, adding the stuff to the store, and setting the model the same way that we did before. And all this stuff is still manually done in code the way that it was before, but we are building the actual column view now through the UI file. How do we do that? Well, we create the object class of the column view here. All this stuff is not too surprising, but when we go to now adding the column view column as a child to the column view, and we give it the ID column1, fine. We give it the title, my first column, same as before, fine. But we can actually create the factory in the XML file now, rather than doing it with signals and binding. Rather than doing it with signals and connecting to the signals the way that we did it before. So you do that by setting the property factory, the factory property within the XML file, and then you create the factory right here by using a GTK builder list item factory rather than a signal list item factory. So if I can just pull up the documentation, they do sort of show you some of the boilerplate XML code here as to how to do it. What it does is it takes the concept of templates, which we haven't really talked about, but we'll talk about in a later episode, and extends it to use it in this type of functionality. And so we take the property name bytes of the factory. It's just one of the only properties that it has. It wants basically raw XML in the form of a template, and that's what the CData guy here does. Is it just says what's coming within this CData tag here. Don't look at it as actual XML to parse right now. Just look at it as text, which happens to be XML. And so it creates basically its own mini XML file right here that creates a template class of the type GtkListItem. And then we set the child property, which we know has to be a widget. So okay, fine. We set the object class right here to be a label. But then what we would usually do here, if we were creating a regular label and giving it just some text, is we would say property name equals label, and then be like hello world or whatever the case may be. But to use expressions in XML, there's a few options. You can use a binding tag, you can use a lookup tag, you can use something called a closure tag. Closure tags, not going to get into today, so don't worry about it. But a binding tag basically allows you to bind the property to an expression through XML. And then you have to tell it how to grab that expression. So we're going to use a lookup tag here to look up the str1 property, and we're going to tell it in advance the type of that property is going to be a demo string tuple. Actually, you kind of have to look at it backwards, because it first grabs the list item, and then it then grabs the str1 as assuming that the type of what the list item is a demo string tuple, which we know to be true. And then we bind the str1 property of what we looked up through the expressions, through the XML, to the label property of the GTK label. And so we do the exact same thing way down here, except instead of looking up the str1 property of the tuple, which we know to be the type of item of the GTK list item, so we look it up, we know that it's a tuple, we grab the str2 property and we bind that to this label for my second column. Okay, so a little bit complicated, but conceptually it's not that difficult. So, okay, let's take a look at cv-ui, and let's run it, and everything's the same as it was before, except now we have a lot less code and more XML, which is a little bit easier to write than some of the complicated GtkExpression code. Now, if we look at one last example, we've got the cv-ui2.c file, and we have the cv-ui2.ui file. And so let's look at the UI file first here, actually. So you can breathe a bit of a sigh of relief. There's not really much new in here. It's just that now we've taken the whole window and all the widgets therein, and we've pretty much just done all of it through XML. So we've got our window, got our scroll window, we got our column view. Everything's done in XML. Even the list store, which is the model, which is bound to the model property of the single selection guy up here, even that's been done in XML. And we've told it that's a list store, and the property name of the, so here the item type is a property of the list store object, and we have to tell it that it's our customized object type. And you can actually, as a special case within GTK Builder XML, even though glistStore does not implement the GTK buildable interface because it's not even part of GTK, as a special case, the GTK Builder API allows you to use list stores in XML, and you can add children to it almost as if it was a widget, except you can do it right in the XML. And so you do child right here like this, and we've added the two children, which is both of which are of type demo string tuple. And then we've told it right off the bat for property name str1 is going to be foo, and then bar for 2. And then for the second tuple that we've added to it, it's going to be bows and boo for str1 and str2 respectively. So it's the same as before when we appended it to the list store, but we've done that now through XML. So that's pretty nice. And then all the rest is the same. Okay, cool. So now if you look here, and if we take a look at the top of the code here, we scroll way down to where we've finished defining the demo string tuple customized object, we're now 83% of the way through the C file. And all we've done is create our customized object. So almost the entirety of the rest of this file is boilerplate. So main function, activate function. The only thing we have to do is we have to ensure that our our customized demo string tuple object is registered with the GObject system before we start to do things with it through GTK Builder. And so we do that by using the gtype_ensure function right here before trying to instantiate the builder. Now, we probably could have or should have done this before, but we didn't technically have to, because the only time that we interacted in XML with our customized demo string tuple was when we used GtkExpression. And one of the special cases with GtkExpression is that the object doesn't necessarily have to exist yet by the time you start utilizing it. And so that's probably why it wasn't giving us a problem. But now that we've started to manipulate the list store and things in the XML using our customized object, it's a must to put the gtype_ensure here. And you know what? If we had it in here before in the cv-ui1.c example, it would not have hurt at all. And we probably should have done it, to be quite frank. But it worked before, we kind of got lucky. But probably should have been in that last example, and it's now a must to have it in this example. So let's quit these files here, make cv-ui2, and if we run it, same as it was before. Everything's still working, except almost everything now has been done within XML. And pretty much the only thing that we had to do in code was create our customized demo string tuple object. So there you have it. That's a good introduction to ListView, ColumnView, and GtkExpression. If my planning is going to work out the way that I think that it will, I think what we'll do on the next occasion is do a deeper dive into some of these same concepts, and in particular GtkExpression, because it is a bit of a difficult concept to wrap your head around. But hopefully you're able to get the gist of some of the basics in this episode. So I will now sign off. Good night and good luck.